This is a video for section 6.1. First, we're going to review the function notation, and we started this in class. The notation f of x means the rule for x. It's written f with a parenthesis and x. It does not mean f times x, but the rule for x. Anything in the parentheses is what you substitute for x in the formula. Example, f of x is 3x plus 2. Therefore, the function of 2, I'm going to substitute 2 for x. 3 times 2 plus 2. Function of a, 3 times a plus 2. Function of x squared, 3 times x squared plus 2. In this example, f of x is x squared plus 2x plus 3. What is f of 5? Well, I'm going to take the 5 in the parenthesis, and I'm going to put it in every place I see x. 5 squared plus 2 times 5 plus 3. F of negative 3, every place I saw an x, I'm going to put a negative 3. Negative 3 squared, don't forget your parentheses, plus 2 times negative 3 plus 3. F of 2x. 2x, quantity squared, plus 2 times 2x plus 3. Now, functions can be added, subtracted, multiplied, and divided just like numbers can. If we have two functions, f of x and g of x, we can add them, f plus g of x, by simply adding the function of x plus the g of x. In this example, we're adding 2x plus negative x plus 5 and getting x plus 5 after we simplify. Subtracting f minus g of x means I'm simply taking f of x and I'm subtracting g of x. Here's f of x, 2x, and I'm subtracting g of x. F times g of x, not surprisingly, is f of x times g of x. Here's f of x times g of x. F divided by g of x is f of x divided by g of x. Let's try some examples. Given f of x is 3x squared plus 7x, g of x is 2x squared minus x minus 1, find f plus g of x. That's going to be f of x plus g of x. F of x is 3x squared plus 7x. G of x is 2x squared minus x minus 1. We're adding them. We end up with 5x squared plus 6x minus 1. If I was finding with the same two functions, f minus g of x, I would take 3x squared plus 7x, and I would subtract all of g of x, 2x squared minus x minus 1. Taking the negative through, that becomes negative 2x squared plus x plus 1. And I would get x squared plus 8x plus 1. If I was multiplying f times g of x, I'm going to multiply 3x squared minus 2x plus 1 times x minus 4. And this is what we did last chapter. We have to FOIL. Take each term times each term. X times 3x squared, 3x cubed. X times negative 2x minus 2x squared plus x. Now I'm going to take negative 4 times everything. Minus 12x squared plus 8x minus 4. Collecting like terms, I have 3x cubed minus 14x squared plus x, 9x minus 4. F over g of x f of x is 3x squared minus 2x plus 1 divided by x minus 4. Well, we should look at this quickly to see if we can simplify it using synthetic division. 3, negative 2, 1. The solution of that is 4. 3 times 4 is 12. 10 times 4 is 40. And no, it isn't going to come out as an even factor, so we'll leave our answer in this radical form here. Let's try a couple of these. Find f plus g of x, f minus g of x, f times g of x, and f over g of x for each f of x and g of x. So number 1, if my f of x is x plus 5 and my g of x is x minus 4, my f plus g of x is x plus 5 plus x minus 4, or 2x plus 1. Go ahead and try f minus g and f times g using those same ones. Let's look at number 4. This is a little bit more complicated. My f of x is 3x squared. My g of x is 5 over x. So my f plus g is 3x squared plus 5 over x. We can't simplify that. Let's look at f minus g of x. 3x squared minus 5 over x. F times g of x. I'm going to multiply the two functions. 3x squared times 5 over x. I can simplify that. Here's an x squared and here's an x. 3x times 5, or 15x. F over g of x, 3x squared divided by 5 divided by x is the same thing as 3x squared times x over 5, 3x cubed over 5. That should give you the basic on what to expect on this homework. Here's a couple extra practice problems here, and then on the IXL. They're all the same way. You're going to use the same operations you've used on numbers on the two functions by adding them together, simply taking the f of x, adding the g of x, f minus g, taking the f of x, subtracting the g of x, f times g, taking the f of x times the g of x, and f over g, taking the f of x divided by the g of x.